So before we talk about B plus trees, let's do one more example on B tree deletion. So let's suppose this is our order 5 B tree and we want to delete, let's suppose 11 we want to delete from here. So if we try to delete 11, what will happen? So 11 is an internal node, right? So when we try to delete internal node, what we do, we replace the node with a in order successor or predecessor, right? So what will be in order predecessor? Predecessor will be 10 or successor will be 12, right? And then we delete that successor or deletion. So how will tree look like? Let's suppose कि we are replacing with in order predecessor. So if we are replacing that node with predecessor, then it will be something like 10 and 21, 2, 5, 9. It will have 12 and 17, and it will have 23 and 27. This will be 51, 67, 32, 41, 53. It will have 53, 61, 64, and last node will have 68, 75, 91, 95. And from here we deleted the 10, and since it was a leaf node and no properties were violated, so simple deletion was fine. Okay, but now let's suppose we want to delete 29. What happens when we try to delete 29? So again we'll follow the same property. We'll replace it with either in order successor or predecessor. So let's go with the predecessor again. So what is in order predecessor? 21. So we'll replace 29 with 21. So the tree will look something like this. 21 will go up there. For now let's keep 21 here also, and the right side wala 51 and 67, and here we have 2, 5, 9, 12 and 17 and 23 and 27. Here 32, 41, 53, 61, 64, and here this is 68, 75, 91, 95. Now we need to delete this 21 from here, right? Because we made copy of 21 up there, so we need to delete it. Now this is again an internal node, right? So we need to replace it with its in order predecessor, which will be 17. So we'll replace this with 17 and delete 17 instead. So what will happen? Let me just make a copy of it. So how things will work? This 21 will be replaced by 17, and we need to delete 17 from there. Now if we delete 17, since it's from the leaf node, we can simply delete it. But when we delete it, we realize that this node has violated the minimum key property, right? So if there is a violation of minimum key property, then what we need to do? We simply borrow one thing from the sibling. So from left sibling it is possible to borrow, so we'll borrow. And let me again make a copy. And how will tree look like? Now tree will look something like this. Okay, this 10 will come here, this, and this 9 will go up. So 9 will go up, 10 will come here, and 12 will be here. And this is how the final tree will look like after deleting 29. As you can see, the nodes are still same, but the tree structure has changed a lot. So depending upon the where we are doing the deletion, we need to propagate the deletion till the leaf node and delete final element from the leaf. And from internal nodes, we'll simply keep replacing that node with either internal in order predecessor or successor, whichever is possible. Okay, so that's how deletion works in the B trees. Now in the next video we'll talk about B plus trees and how to we'll do the insertion in B plus trees and deletions also in the B plus trees. Okay.